Hey everybody, so in this video I'm going to show you some more examples of derivatives of inverse functions and how to find them. So let's just begin with the first problem. And so we have f of x is equal to arc sine of x plus 1. So we could already tell that it's a composite function. And we're going to start by writing the derivative of arc sine and then putting in x plus 1 in place of x. So you should remember the derivative of arc sine, derivative of arc cosine, and arc tan. So the derivative of arc sine of x is 1 over the square root of 1 minus x squared, but we're going to put x plus 1 in place of x, and we would get x plus 1 squared. And then you could go ahead and simplify, and you would end up with 1 minus, then we have x squared plus 2x plus 1. And then if you simplify even more, you would get 1 over square root of negative x squared minus 2x. That would be your final answer. Moving on to the second problem right here. We have sine of arc cosine of x. So we're going to begin differentiating. And you would get cosine. So the derivative would be cosine of arc cosine of x, and then you multiply the derivative of the inside, which is negative 1 over square root of 1 minus x squared. And you can go ahead and simplify even more by drawing out a visual representation here. So if you had an angle u, and then so what this means is we have the angle of u whose cosine is x. That's what this means. So the cosine is x. The cosine of u is x. That means adjacent over hypotenuse is equal to x. That means the adjacent side is x, hypotenuse is 1 in order for it to be x. And there you go. So you can complete this problem by finding the cosine of this scenario right here. So the cosine of that would be adjacent over hypotenuse. So that means this whole thing right here is just x. And if you multiply x by what we have here, your final answer should be negative x over the square root of 1 minus x squared. I hope that wasn't confusing. All right.